and I wasn't here Friday. Cool. So 6.2 matrix multiplication and versus determinants. Let's see how much we can get through today. It'd be great. But there is a whole screencast of this already uploaded on Haiku, so that should be helpful. All right, so 6.2. So we're going to start with multiplications of matrices. So I feel like maybe this is going to be a little step in the, easier direction. Maybe you've done this before, especially if you did this on Alex. Like, it teaches you how to do it. Do we already know, how do you do matrix multiplication? Do you know this method? Nope. Okay. Across and down. Yeah, maybe. Okay, whatever. We'll work on it. All right, so remember, throwback. To multiply matrix A by B, the number of columns A must be equal to the number of rows. Right, so that's what this is saying right here. The number of columns must be equal to the number of rows. Then the product A times B will have the same number of rows as A columns of B. So then this would be the dimensions. What would happen if I tried multiplying, instead of A times B, what if I did B times A? What if I did, huh? Would it be?
Oh, no.
If I did 2 by 4, so B times A, and A was 3 times 2, remember, these two have to be equal.
Mm-hmm.
B times A does not exist because the number of columns of B does not match the rows of A. Instead, what if this was a 3 instead? Could I do that?
Yeah.
Okay, and what would the dimensions of B times A be? 2 by 2 would be the resulting dimensions. Okay, so every time you do one of these problems, literally list out the dimensions of each one, see if the inside two match, and then the outside two dimensions will be your answer. All right, so let's go ahead and let's work on matrix multiplication. So if A is an n by r matrix and B is an r by n, okay, so pause a second, right? The number of columns of A has to match the number of rows of B. Do they match? Do they match? Rows of...
Yes, they do.
Okay, they do. Check it out. They match. Okay. Then the product is an m by n matrix, aka like the outside two.
Is that,
Obtained by adding, sorry, what?
Oh, m by n? Wait, what? I can't see it.
I don't know.
It's on your paper. It's on your paper if you get out your notes.
Where's your A by B?
What do you mean?
If A is an A-N times R, where is that?
If A is an m by r matrix, so literally A's dimensions is m by r, B's dimension is r by n, so the columns of A have to match the rows of B, because I'm literally doing A times B. The resulting dimensions will be, the resulting dimensions, it will be a m by n matrix. Okay. Whew. All right, so if I want to find, so how do I actually multiply? So what I'm going to do is you go across your first dimension. So I'm going to be going across this way to the right and down the first column. Across the first row, down the first column. So I'm taking A11 times B11. So that's what this is saying. And that's what the first top left corner of C will be. So I'm going to be going across A, down the first column of B. So everyone raise your left arm. Raise your left. Right? And then act like you're poking the person next to you. Nope. Do you see how I'm going across my body? So you're going this way with your left. Have your left arm out. Have the left arm out. Everyone's left arm out.
Oh, across your body?
Okay, so I'm mirroring you. Here's your left arm. This is your left arm. Now point it this way. Okay. All right. Now take your right arm. So I am mirroring you. This is your right arm. Now go down.
Down.
Okay. Do it at the same time. Do it at the same time. Do it at the same time.
This is like one of those.
Yep.
Yes.
So I'm showing you how to do it. You go across the first, down the second. Across the first row, down the first column. Right? So I'm going to be going across the first row, down the first column. Yay, nay, maybe, okay. All right. So I have A11, B12, and that makes C1. So I go across the row, down the column. So where will this fit? Where will this be? Do we remember how to do this? Okay.
I wish we did.
I have no idea what you're doing.
Okay.
No, I don't think we did this yet. We didn't do this part yet.
Okay. So okay. Here, where should I put my blue dots? I'm going across my row, down my column. Where do I put, like, where does this multiplication go on my C? So if I take this first one, A11 times B11, where do I put it?
C11.
C11.
It looks like CIJ.
C11. Okay. If I take A12 and B21, it's a trick play. You add them together. So it's the C11 is going to be the total addition of the first row and the first column. Okay. You know what? This is really confusing. Why don't we just go to the example? Let's just do the example. Okay. Find A, B, and BA if possible. So let's do A times B first. Yeah, I hear you're confused. It's okay. We got this. Is A times B possible? What's the dimensions of A? 2 by 3. What's the dimensions of B? 3 by 2. So if I'm multiplying a 2 by 3 and a 3 by 2, is it possible to multiply them? Yes, because this has to be equal. What will my resulting matrix C be? What will the dimensions of the resulting matrix?
2
Okay, so we're going to be getting a 2 by 2 matrix. All right. So what I'm going to do is I'm going to rewrite. So A times B is going to be, I need to find is going to result in, yeah. A times B will result in.
Yields to.
Okay, so I'm writing this again. Multiplied by 2, -1, 9, 0, 2, 3. Okay, so it's going to be a 2 by 2 matrix. So I have 4 spaces I'm going to be filling in. So the top left corner, I need to go across the first row, down the first column, and I'm going to be multiplying like every single step together. Okay, what I mean by this is I'm going to take -2 times 2, add it to 0 times -1, so I'm going across and down, across and down. All right, 0 times -1. What's the next one? Across, 3, down times 9.
Wait, but usually if it's like the same amount of rows, you just go like, you would go like -2 times 2 and then 0 times 0, right? If there were 2 rows and 2 columns. No?
No, because you go across the first matrix, down the second.
No, but before when we were doing it, or was that addition before?
Addition,
Addition,
subtraction.
subtraction. Oh,
Yep.
okay.
Multiplication's a little different. Okay, so what will the top left element be in my matrix? What is?
Wait, hold up.
Okay. So I'm showing you how I'm gonna have, it's a 2 by 2 matrix, right? I'm gonna have like 4 numbers to fill in. So this is the first number. If I wanna find the, it's all right, just stick with me, okay? Just stick with me. It's gonna be a little confusing, but you got it. If I want the top right number, literally, where is this piece located? This is the first row, second column. So I want my first row multiplied by the second column of my second matrix. What I'm going to be doing is taking this first row and the second column. Hey, so ready for this one? Negative 2 times 0 plus, and I'm just matching each one.
Okay, I'm so confused. Where did you get to that?
Okay, so for this first number, you ready for this? This first number. Negative 2 times 2, ready? Go across with the left, down with the right. And then 0 times negative 1, 3 times 9.
Okay.
And that was this guy. I have to add them all together and find a number, but then I want to find this one.
Oh.
You have a question?
Yeah. If it's so, what it's like, you know how you said like the inners are 3 and 3, and the outers are 2 and 2.
Yep.
So by the commutative property, can you switch those and it's the same? That you can.
Well,
So who
okay.
said you have to start by 2 by 3 and 3 by 2?
So it said A times B.
Oh, and the opposite.
And then
would be
after
A.
this, I'm going to be checking B times A.
Got it. Okay. That's
Yep.
my question.
All right. All right. So this next time, to find, maybe this will help. To find A11, actually this is C, this is matrix C. I get my row, like I look at row 1 here, column 1 here. If I'm wanting to find C, row 1, column 2, C1, 2, I take the first row from my left side and the second column from my second matrix. You get the rows from the left matrix, the columns from the right. So I'm going to be going through, and I'm going to take first element times the first element, right? So first thing in the row, first thing in the column multiplied together. Then you take the second thing in the row times the second thing in the column. So this is going to be plus 0 times 2. And then I'm going to take the third element in the row times the third element in the column, right? So I'm going across and down at the same time. 3 times 3 is 27. Oh, sorry, 3 times 3.
Negative 23 is the answer.
And then so I'm gonna just show all the work first. All right, so I'm trying to color code it so you can see what I'm doing. All right, so this is C. What's the row here? What's the row with my pink? 2, column 1. So I'm getting the second row from the first matrix, and I'm gonna use the first column from the second. So left hand, you're going across the row, right, you're going down the column. All right, so what this means is I'll take 5 times 2 plus negative 7 times 1 plus 1 times 9. So you're working your way.
I get it now.
It just takes just gotta try it out. Yes, Nathan?
What's that like type of matrix called? Is it like a mega matrix or something? Super matrix?
I don't know what you're talking about.
Like the matrix that's the result of all of this.
Resulting matrix? I don't know. What do you call it? The result? We don't have a special name for it. Okay. Let's try the last one. So I have a lot of colors on here. Let me get rid of that one. What's another? Purple. So I want the bottom right corner of my resulting matrix. Remember how we said it was going to be a 2 by 2? We found out the dimensions. So if this is the second row, second column, I'm going to take the second row, because you get the rows from the first matrix, the second column. All right, so remember, you start left and top, and you work your way to the right and down, to the right and down, to the right and down.
Oh.
That's why I had you guys do the whole funky thing. Hey. Okay. So I have 5 times 0 plus negative 7 times 2 plus 1 times 3. All right. So I've written out all the multiplication because I want to show you multiply these two, plus multiply these two, plus multiply these two, and then when you add up all those, that is the number you put in that space on your matrix. So let's see what the solution would be. Okay, so if I go through first one, negative 2 times 2, negative 4, plus 0, plus 27. So I believe Sarah said it was 23. The top left?
Negative 23.
No.
Oh, yeah.
So.
That's 20.
Yep. What about the top right corner in the light blue? 0 times 0, oh, 27. 9, oh yeah, 3 times 3 is 9. Cool. What about the bottom left corner? 10 plus 7, 17, plus 9 is 26. So I'm really trying to like show you with the colors what's going on. All right, let's do the purple. Negative 17 plus, no, negative 14 plus 3, negative 11. So that's it. This is your solution. This is A times B. This is A, B. Oh, you can't even see that.
That's your answer. You ready to change?
A, B, this is the matrix. That's it. I have my numbers. It's a 2 by 2 matrix. I'm done. I'm good. The second part of this is find BA if possible. So order when you multiply matters. With matrices, it matters because the columns of your first matrix have to match the rows of your second.
Okay.
Yep. So I'm just going to make this a little smaller. We found AB. Check. That's done. That's done. We're good. But now I need to find B times A if possible. So can I do B times A? So B is 3 times 2. A is 2 times 3. Okay, guess what? The insides match. What will my resulting matrix C be?
3 by 3.
Okay, yeah, the resulting will be a 3 by 3. So we can do it. Am I good to scoot over a little bit? You say no?
No.
What do you mean
That's fine.
scoot over? I don't understand.
Like, move it over so I have space to write.
Just like,
I did not say
Like, look, that's what I mean by move over.
wait.
Okay.
Oh, like, are we done copying ab?
Yep.
Wait, where should I write it?
Did you, oh, you used the whole space?
Yeah.
That's awkward. Maybe on another piece of paper? I will admit, I should have left more room for this. Yep.
No.
Yeah, but what is this whole AB thing?
Okay, questions one at a time. One at a time. Let's have Nathan and then I'll answer Sarah's question.
So you know how you just did that thing, like you were like, okay, it can work because it's a 3 by 3. So an example of something that wouldn't work is it has to be the same number, right?
The inside has to be the same. The inside. So I went through and I made sure like the columns of the first matrix I'm multiplying is the same number of rows of my second. And so I had an example up above where it was like, oh, hey, check it out. I could do A times B, but when I tried to do B times A, originally it wouldn't work because I had a 4 here, and 4 were not the same number, so that I couldn't multiply them.
But the outside numbers can be different.
Yeah, that's fine.
Why do the inside numbers have to be the same?
Because of, this funky little dance move I just taught you. Going across the row has to be the same number. It has the same number of columns as rows. It's just, yeah, I can go in more detail. It's just you have to do it that way. What's wrong? Do you need to be separated further apart? Okay.
No.
Okay. So let's do B times A. So we're gonna have a 3 by 3 matrix.
No.
There it is. I stole the other one, but you can have it.
You know you can do all this on your calculator.
Yep, you can. So, all right. So let's find this one. This is I could write this a little differently to show you. Let's see, 2, 0.
Wait, are we allowed to use our calculator for this or no?
There'll be a section where you can't use it. So. Because I have to make sure you know how to do it, not just your calculator.
What are we gonna use it for?
What are you going to use a calculator for?
No, what are we gonna, like?
If you ask me where you're going to use this in life,
No, in
I'm
real
done.
life.
I'm
When
done.
we want to use it in like real life, wouldn't we just be like, oh, yeah, let me keep my calculator handy, like, I
Yeah.
understand.
But also, like, in real life, you have to, like, use your brain and solve problems. So I'm trying to have you guys, like, you know, try that at least once in your life where you have to, like, critically think. So that's what I'm trying to do. All right. So let's go ahead, let's do this. So rows and columns. Rows and columns. I want you guys to, like, engage. I want you to be engaged with the math. I want you to, like plug in and not just be, like, you know, like a monkey, like, this is blah, 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 you know, like rote repetition. I want you to, like, think, connect with it, try to solve the problem and, like, understand why it's this way. Okay, so if I'm doing B times A, first matrix, going across the row, second matrix going down the column. So I'm going to be going across the first row, down the first column. And that will be my first thing right here, in my top left corner. All right, so 2 times -2. Shh. What is this noise? What is this noise? What's wrong? What's wrong?
Me?
Yes. Do you have a question?
Yeah.
Okay. Then let's not distract others. Okay. So I'm gonna go across this first row down the first column. So 2 times -2 plus 0 times 5. What will this be? -4. -4 goes right there. Awesome. Let's go. Which way do you want to go? Do you want to go across? Let's just go across the first row. Okay. So now I want the part that's right here. How do I know what to multiply to find that? It's part of the first row, second column. Row 1, column 2. Oh, okay.
How'd you get -4? We don't like real one.
-2 times -2 is -4. Plus 0 is still -4.
Wait, what order are we going in?
So I'm going across. So I'm going to fill out this first row, second row, then I'll fill out the third row. So I'm going to go down the rows. So I'm gonna hit this one, then I'm going to go here, and then I'll just go across the rows. Okay. So this is technically, I'm going to label this matrix C. I'm just going to do this matrix C. So this is row 1, column 2. So anytime, this is for your row 1s, this is how you find your row 2s, this is how you find your row 3. So more or less, the way I set it up is like, oh, which one should I use? This whole first row is going to be using this row over here. This whole second column is going to be using the second column. So that's another way you could set it up. So I'm trying to like show you visually. How do you know which ones to use? No, okay, whatever, that's fine. Okay, oops. So I'm going to be doing 2 times 0 plus 0 times -7. What will this be? 0. So that's what I'll fill in here. Then I'm going to be, let's see, this is the third column, so I'm going to be highlighting this third one on the end. All right, and then we're just going to be multiplying again. So 2 times 3 plus 0 times 1. So I'll just fill in 6 right here.
Wait, how did you do this?
So across
each
the
row
first,
3 times.
down the second. 2 times 3 is 6. 0 times 1 is 0. 0 plus 6 is 6. This other one right here, I'm going to be doing
the 1 too.
where?
What about the column?
0 times 1 is 0.
You
No, but
won't
why
give
did-
them any attention.
Like, wouldn't you just use the 3? Wouldn't you just do non Wait, I just don't get, like,
So as you're looking at this, you go across the first matrix, down the second.
would I be allowed to draw it out like how you drew it? Like
This is beautiful. This is, yeah, showing you another way to like see it.
And if I draw it every time, that's like totally
If you draw it this way, perfect. You'll get the right answer at least. Because then it like eliminates confusion. You're like, okay, cool. So which row am I using? The one to the left. Which column am I using? The one above it. And then you can just multiply that way.
Beautiful. I get it.
Why isn't it like 2 times 3 and then 2 times 1 and then 0 times 3?
Because that's not the way it is. It's literally 2 times 3, 0 times 1. Because you're moving both your fingers, not just one of them. You're moving them at the same time.
I don't. Alright.
Right, so we're done with the first row. let's go to the next row. So guess what? I'm going to be using row 2 for all of these.
Yeah.
And then for the first column, I'm going to be using the first row. Yeah.
What does that mean?
So I'm highlighting the fact that, like, okay, to find this number right here, I'm going to be using this row, and I'll be using this
Oh, you have to
column.
start with all of them all over again, right?
I'm doing
I mean, you have to start with that column all over again.
All right, so I have -1 times -2 plus 2 times 5. So what will this be?
12.
12. Okay. So here I have, to find the middle, can you see how it's darker where they're crisscrossing?
Yes.
I want to find that number. So I'll be using -1 times the first thing in the column, which is 0, plus 2, which is the second thing in the row, times -7, which is the second thing in the column. This will be -14. Okay. See, this is doable. All right, how do I find the third thing in this?
We use the third column in the second row.
Surprise! Surprise!
-1.
It's like there's a pattern. -1 times 3 plus 2 times 1.
-1.
-1. All right, now guess what? I moved on to the third row. I'm going to be using this every time.
Let's go, guys.
So, this time,
It's good. I like that setup.
I think it's helpful. It's helpful. All right,
-3.
9 times -2 plus 3 times 5. -18 plus 15, so it's -3. Okay, so now I want this bottom one. Where they overlap? How do I do this?
-21.
So 9 times 0 plus 3 times -7 is -21.
30.
All right, let's try last one. So 9 times 3 plus 3 times 1, so that's 30. Guess what?
What?
We got it. We're done with the problem.
I don't know.
We're done with the problem. So, example 1 was find A, B, and BA if possible. We did. We found both because they both were possible. All right, so let's do this next one. Example B. Can I multiply these? Can I multiply them?
Wait, it's wait.
What are the dimensions? What are the dimensions of A?
3 by 1.
1 by
1 by 3.
1 by
Looks like you
3.
can.
3 by 1.
Oh,
It
so
looks
you
like you
can.
can.
Rows.
You can do it backwards. You can go backwards.
One by
You can
My
be
country.
You can do it. You
I
can
know
do
it's
it.
one by 3. Oh.
Row
You can
by
do it.
column.
Row by
And
column
this
by
is
column.
3 by 1.
Oh, you can do it.
Row by
Do
column.
it.
Okay, so if I do A times B, guess what? These middle two match. If you do A times B, you literally list the dimensions. What will my resulting matrix be?
Why are you doing that?
Did I ask you to do that? What is that? The thing will just be 1 by 1. It will be. Does she know?
Match versus this is the result. The resulting will be a 1 by 1.
What is a 1 by 1 look like?
Literally, it's one number.
Oh, it's just a one number.
One row, one column, literally one number.
It's just like
I
one
know
little.
that.
one little
Holy
key.
cow.
Janine knew it. Okay.
Because she's in the math league.
Yep,
I took the test.
you did.
She did great, guys.
Yeah.
Janine. Why?
So I'm setting it up because I know I'll have one, like a 1 by 1 matrix. This is it.
You have to write it like that.
No, but visually it helps. You also could like go through. I don't know, it just helps.
Tissue here.
I threw him to. Threw him to my map.
What? I like it this way. Are we talking about the drawing?
No.
Alright, time out,
Oh,
time
I
out
thought we
tissues.
were talking about like the drawing.
Wonderful. Okay, so let's keep going. Let's keep going. So across the row, down the column, -2 times 4 plus 1 times -6
Yes.
plus 3 times 5. -8 plus -6 plus 15, so it's -14 plus 15, which is 1. Yeah, that's it. Guess what? This is my 1 by 1 matrix. This is AB. That's A times B.
It's a cute little.
Okay, let's do BA, which is the opposite way.
And it's just one?
Surprise, it's the answer. That's it, it's the number.
It's unsatisfying.
I mean, -8 minus 6 plus 15.
Yep, -14 plus 15 is 1.
Will we have calculators? I really think.
We'll see.
My nose is
Let's
eternally
see.
stuck again.
I need to. Alright, let's see if we can do B times A. Can I do B times A? So if I do B times A, it's 3 times 1 by, let's see, multiplied. A was 1 by 3. As long as these match, I will have a resulting of a 3 by 3. So this one isn't too bad either. So if I have B times A, B is going to be here. So that's 4, -6, 5. Here's my A. My A is -2, 1, 3. So I have 3 by 3. Okay, so let's start right here with my first number. So what do I multiply? What do I multiply? What's 4 times -2? -8. Okay. Let's do this one. What's 4 times 1? Nice try. 4. Let's do the last time. Okay, 3 times 4. Do you see a pattern? How beautiful. How nice. Okay.
Why do you set it up like that though? Like why is the A
It makes so the first, right, because the whatever matrix you're multiplying first, that's going to be your row one, you put on the left side. Whatever is multiplied second, so here I have A second,
It's gonna be the column.
is going to be the column and I write it on top. That way I can do a little, crisscross and I see what to multiply. All right. Please focus. Okay. All right, so we're done with our first row. Let's go to our second row now. So what will this one be? Sarah said 12. What about the next one? -6 and -18. Because if I would instead highlight these, literally I'm just multiplying. There's only one thing to multiply, so I don't even have to show you the work. Okay, let's go to the third one. Oops. Okay, so now I'm here. Can we fill out the bottom? Do we see the pattern? -10, 5, 15. Cool, we're good. Alright, so that's properties of matrix multiplication. For any matrix C, A, B, and C, for which the matrix product is defined, aka I can actually multiply them. So order of multiplication is important. So the first thing is the associative property of matrix multiplication. If I have matrix A times B and then multiply by C, I could do B times C first and then A. It's just the order of you multiplying them, like which one's on the left side and which one's on the right, that part matters. But not necessarily like the order that you actually multiply them. Okay, cool. This is crumpling. Is this you? Okay. So here, if I take A times B and then multiply by C, that's the same thing as if I would multiply B times C first. But notice I don't change the order. I'm not doing C times B times A. I still have the same order left to right. So that's the part that matters, is the part left to right. If I want to multiply by a scalar, I could do it after I already multiplied these two matrices together, or I can multiply one of them by it, and that's the same thing. I've already more or less gone through the rest with you before. Left distributive property, right distributive property. So either way, You're going to be multiplying both matrix by matrix C. Okay, so let's recall some important little information. So recall the multiplicative identity. Do you remember from algebra what that means?
The what? Sorry.
Multiplicative?
Yeah.
What does it mean?
It's
Multiplication.
if you put it by 1. Shoot. Hold on.
1 times A is equal to A.
Oh.
Oh yeah, duh. Oh,
Okay.
1. I said that. Identity.
Yeah.
I said that.
So the identity matrix, I, is a matrix such that if you multiply A by it, it's going to be
1.
I.
Oh.
Oh, sorry, that should be A.
I'm sorry.
It's literally like multiplying by 1. Sorry, I think I wrote that wrong in your notes. It should just be, you take A times your identity matrix, you should get your original matrix back. So this is the, so the multiplicative identity of a square matrix is the identity matrix. Okay, so let's look at this. Here we go, identity matrix. So the identity matrix is, words. The identity matrix of order n, denoted I of n, is an n by n matrix, so it's a square consisting of all ones on its main diagonal. So we learned what main diagonal was already. Literally top left to bottom right. All those are ones. Everything else is a 0. Yeah, more or less that's it. Cool. The identity matrix, everything's zeros except the main diagonal, and those are just ones. That is the identity matrix. Okay, said that 5 times. So for example, so with real numbers, this is what it would look like. So this is the multiplicative identity. So 5 times 1 is just 5. Okay, so with a matrix, what this looks like is matrix A times my identity matrix, so that's an I, is literally going to give me my matrix back, my original matrix back to me. Yep.
Is there like a fixed identity matrix, or like it can be different?
You can have different sizes depending on the matrix you have.
But it's
You want to
always
like
just
fit it.
consists of, like,
It's the main diagonal is all one. So you can have a 2 by 2 where literally it's going to be 1, 0, 0, 1. Like this is a 2 by 2 identity matrix.
but it's always
You could have it be a 3, but the main diagonal are always ones. Okay, so the key is you can multiply your matrix A by the identity to get the exact same matrix back. You multiply the identity matrix and you get the exact same matrix back to you. Right. So that's the identity. Inverse and determinants. The multiplicative inverse of a number A is 1 over A, or A to negative 1. So literally, like, this exact same thing, if I had x squared equals, I don't know, 16. How do you get rid of a square? Square root, which is the same thing as putting it to the 1/2 power. So you're putting it to like you're doing the inverse operation. Instead of squaring it, you're taking the square root. It's the inverse operation. So inverse is literally like the total opposite. So this first part should just be a little review. Right, so recall the multiplicative inverse of a number is just 1 over A. How do you get rid of, like, if you have 3x equals 9, how do you get rid of the multiplying by 3? Multiply by the inverse, which is 1 over 3, sorry. Dividing by 3, same thing as multiplying by a third, it's the inverse that makes it cross out. That's all this is saying. Inverse of number A is 1 over A. So the multiplicative inverse of a square matrix is the inverse matrix. Alright, so what this means is if I want to, since we can't divide by a matrix, what we do is we multiply it by the inverse. Because up here, you know, instead of multiplying by a third, I could have came up and been like, okay, just divide each by 3. Right, so that solves for it, but we can't divide by matrices. So what we do is we multiply by the inverse. So the inverse of 3 is a third, right? So it's multiplying by the inverse. Same here. You can't divide by matrices, so you multiply by the inverse. Yeah, it's just like that's a thing. You can't divide by matrices. Oh my gosh.
I love the determinant. It's amazing.
So a lot of stuff like theoretically you've seen before. Since we can't divide by matrix, you multiply by the inverse. Alright, so to determine whether A and B are inverse matrices, check if A times B is equal to identity, and if B times A is the identity. A singular matrix has no inverse. Okay, so here, what this means is if this is true, then they're inverses. If true, they're inverses. It's like if I take 3 times a third, what's that equal to? 3 times 1/3.
1.
That's 1. Is that the same thing as 1/3 times 3? Yeah, so they're inverses. If I take B times A and I get the identity matrix where it's just a diagonal is all ones and everything else is zeros, then I take A times B and I get the identity matrix. Guess what? They're actually inverses. Woohoo! Okay. Yes.
Oh gosh.
They're inverses. Sorry you can't read those. Yeah.
It's zoomed in 400%.
Yep.
So nice. I noticed.
Okay. If the matrix, I don't know what you want. Like, I don't know what you want from me. I don't
I'm not
know.
expecting any response.
Okay. If the matrix has an inverse, guess what we call it?
Inverse matrix.
Invertible. It's invertible. Check it out.
Invertible.
Yep, it's invertible. Alright, cool. So we can try this first one. A singular matrix has no inverse. Just real quick, what does singular matrix mean? What's a singular matrix?
1.
A 1 by 1.
one.
Aha, it has no inverse. Trick. Okay. Determine whether A and B are inverse matrices. So meaning, I have to multiply A times B. Should get an identity matrix if they're inverses. Then I have to do B times A. I should get inverse matrix. I should get an identity matrix if they're inverses. Yep. Perfect. So 4 minutes. All right. So let's check. So we'll do this first part. Check if A times B is equal to I. And guess what? This is a square. 2 by 2. So they're going to match. I can multiply them both ways. We'll be okay. All right. So A, so I have 5, 6, 4, 5 is A. B is 5, 6, 4, 5. Okay. Then I'll have a 2 by 2. To find the first piece, I'm going to be having 5 times 5
So you should get the same answer when
plus
you reverse
6 times 4.
Is there Brian? Is there Brian?
Did I write this wrong? This is negative 4, sorry.
Is there Brian?
What?
So if you do the B
I should get an identity when I do the
it should be the
opposite.
same exact answer. Okay.
I should get the identity for both of them. So I got 1 here.
But aren't we trying to find a singular matrix?
Well, I'm trying to find the identity. If A and B are inverses of each other, you should get an identity matrix.
But it's not a singular matrix.
No, a singular is literally
1, 1.
No, it's just 1.
Yeah, 1 by 1.
an inverse doesn't. Okay.
Oh, cool.
A singular is literally a 1 by 1 matrix. So,
So, yeah.
right, so it won't have an inverse. Okay, so let's do the second part. So 5 times negative 6 plus 6 times 5. Oh my god, that's 0. Check it.
Check it.
Check it out.
Okay, let's do these. The top right hand corner is negative 6. Sorry, you can't read that. This is a 6. 4 times 5 times plus 5 times negative 4, so that's 0. Then I have 4 times negative 6 plus 5 times 5. That's 1. Okay, so that's an identity matrix. So this is identity. This part right here is an identity matrix. So we're halfway there. We have to check B times A. So if I do B times A and its identity, guess what? I found that A and B are inverses of each other. It's like 3 and 1/3 are inverses. If you multiply them, they equal 1. If I take A times B and it gives me identity matrix, they're inverses of each
You
other.
can't do B times A because they don't have the middle things that match.
They do, because it's a 2 by 2, 2 by 2, they match, so the resulting will be 2 by 2. Cool. So I'll put the solution up here. We will finish this section next time. So this is an identity as well. So this proves that they're inverses. If you don't believe me, do it at home. Okay, you are good to go.